Hello everyone. Today I am going to discuss about some topics about chapter 7, which are about point estimation, interval estimation, interval estimation, sampling distribution, and test of hypothesis. Test of hypothesis. These are the four topics today I'm going to discuss, and that will end the chapter 7. Okay, what is point estimations? Remember, we discussed last time with electronic associate incorporations data, right? Let me go and open that data. If we go there, here is the data. Chapter 7, electronic associates in incorporation data. So there is a 2500 rows of the managers of electronic associate incorporations data and their annual salary, as well as whether each of the manager completed a training program or not. So this is the data. If you take a look at that, so there are altogether 2500 rows. From these data, first of all, I want to take a sample, a random sample of size 30. So in order to take a random sample of size 30, I just put a column random, and then I write here rand, and then one random number between 0 and 1 is generated. And now if I go there, and then this is the field handle. In this field handle, if we click, then all the empty cell up until 2501 will be filled by the random numbers from 0 to 1. So if I click in there, double click, so it has been filled. Okay, as it has been filled, now I want to sort this data frame, that is column A to column D, by the variable random. So entire data frame will be sorted. So I go to the data and select the first column, and then control shift right arrow, rest of the column is selected. Again control shift down arrow, all 2500 columns including the column names have been selected. After selecting these things, I want to sort this data frame by the variable known as random. So if I sort it, this variable C, it will be changed. So I'm saying, so everything has been changed now. It is sorted, so everything has been changed. So now everything in the format of a random number. From there, I want to select from there I want to select, randomly selecting, I want to select 30. I want to select 30 rows. So these are my 30 rows control, and then I want them to be in here, or maybe I want them to be in there. Let me put it in there. I just want to put it in there. This is my sample. I just want it to be in there. So this is my sample. This is my sample. Okay. Now what's happening? Let me go there. Just paste it in there. Paste it in there. Hopefully it will work. Now this is my sample. From this population, I want to compute average ABG average of population. I want to compute standard deviation of population, STD, STD of population, and then I want to compute here proportion of population. This is what I want to consider for this data. In order to compute that, if I go there, in that way, if I write average and then select all the salaries, and then I got the average equal to that. In this case, if I want to do the STD, standard deviation of sample, which is this standard deviation of sample, and then if we select all the values from here up until there, then we see this is the standard deviations that we have computed. This is the standard deviations for the population, so I have to put there P. So this is the standard deviations, and I want to compute now the proportion. That means yes, how many of these are yes, I want to compute that. So count if, and I have to select all from here up until there, up until last. And then after doing these things, then I want to do here yes, and after doing here, then I divide it by 2500, so it will be proportion equal to 6. So this is what the proportion that is coming from the populations. Okay, this is what coming from the populations. I just copy these things and paste it in sample here. I just want to paste it in there. So this is the populations thing. Okay, now this is the sample that I took. From this sample, I also want to compute this average ABG S, and then STD S, and then PROS, proportion of sample, standard deviation of sample, and mean of the sample. If I want to do that, I have to go there and write it like this way. Then this is the, and then if I want to do it STD, standard deviation, if I want this way, then if I select all the way from here to there, then this is the standard deviations. And proportion, if I want to compute like proportion, then it should be again count if, and then I have to count the number of yes, which I can do by writing yes, and then I have to divide it by 30. So this is the proportion. Let me see the proportion. 1 to 2, 3, 2 to 31, like this. Now see that one. So sample proportion is exactly equal to the population proportion. And then standard deviation from the sample is 3779. Population standard deviation is 3999. Population average is 7100, 800, and sample average is 7100, like this. So these are called the point estimate. This is called the point estimate obtained from a sample of size 30, and this is a population point estimate equation. So point estimate means when you have a sample, from there you find average, standard deviation, variance, all of this. This is called a point estimate. So point estimate formula to compute mean, point estimate formula, sum of 30 I goes 1 to 30 xi divided by 30. Okay, this is mean. And then what is standard deviation? Standard deviation equal to 1 over n minus 1 sum of xi minus x bar square. Okay, this is the standard deviation that we obtain from the sample. So if I want to find the population mean will be obtained, goes 2500, I goes on to 2500, capital Xi divided by n, which is equal to 2500. And then similarly, if someone asks me to find the standard deviations, then it will be 1 over capital N sum of 2500 I goes 1 to, and then xi minus mu whole square, and then here is a square root. So this is the way you can compute mean and standard deviations for the population. In here, mean and standard deviation, and this is for the sample. So population proportion is obtained by there are 1500 persons who completed the test out of 2500, so the result is 0.60. And here is p hat equal to x small x divided by n, my n equal to 30, and then x equal to maybe 19 or something, or 18, something like that, maybe 18. So 18. So this is the sample estimate. So point estimate means you have a data, you are specifically estimating the mean. Okay. So now I want to discuss about interval estimations. Okay. Let me go there. Let me go there and take that one. So if I want to take that one, now I want to find the interval estimate. How can we compute interval estimate? Interval estimate means in a state of computing, or in a state of estimating mean by using one value like this, xi minus x bar over n, we want to estimate a range where there will be a lower limit and there is a upper limit. Okay, there is a upper limit, and this is called the interval estimations, and the mean fall within this limit. The smaller the interval, the better the approximation, the better approximations the mean is. For example, if I want to visualize these things, how interval estimation working. So suppose this is the, my graph is very bad. This is the mean equal to suppose 10. Okay. So 10 means average amount of money spent for the lunch by the student at USM. Average amount of money, $10 they spend. So I went to 100 student, first 100 student, and asked them how much money you spend for the food. And then they give a 100 different number, and I use this formula x bar plus minus z 0.95 s over square root of n. So the 100 number that student gave us, like $9, $7, $12, $13 that they spend for the food, I use those 100 number to compute their mean, compute their standard deviation, and equal to 100. And this the 95 means I am using 95% confidence interval. What does that mean? That means like this. So this is the 95% confidence interval. Okay, this is the 95% confidence interval that in this case, 95% of the frequency fall. And in such a cases, this value is negative 1.96. This value is positive 1.96. Okay, so I use this value z equal to 1.96. This is the 1 minus, which is equal to this minus. There is a plus, this plus equal to that plus sign. Okay, and then x bar, s, and n. So in this way, if I went to the first 100 students and compute their mean and standard deviation, plug in this value, suppose I got the value 9.1 to 11.9. So this is 11.9 and this is 9.1. Another time I went to another maybe 100 or 80 students, I construct confidence interval, I got again confidence interval like this way. Second one, minimum maximum. I go again another group of students, I got this. Similarly, I got another group of students, I got in here, so it did not cover. Another way, I go to the another group of students, it did not cover. So that means this group of people, they spend really very small amount of money. Okay, and they spend a lot of money for the food. They spend a lot of money for the food. So that means they do not cover the mean. They do not cover the mean. And so in this way, if you continue eat 100 times on an average, 95% of the time, this interval cover the true mean. And that interval is called the confidence interval. 95% confident that our mean cover the in this way, if the interval is computed, then that interval is known as the interval estimate of the mean, and we call it 95% confidence interval, because 95% of the time on an average, true mean is covered by the interval. So that is why it is known as the interval estimate. So now how do we compute interval estimate? By using our data for manager salary, right? So let us go there. I want to construct it from here. So manager confidence interval, I have a mean which is this, and then I have to put layer like this, z equal to 1.96 times I have a standard deviation which is equal to this, and then I have to divide it by square root of 30, because I have a sample of size 30. So I got 70,000 like this. So it's a lower limit, and then upper limit I want to consider in here. Again, I should go there. This is the average, and then this is plus sign. This is 1.96 times, then this is the standard deviations divided by SQRT, square root of 30, and then in that way I got this. So this is called the upper limit. This is called the upper limit. Okay, upper limit. So 95% confidence interval for the mean, 95% interval estimate of mean of the annual salary of the manager lies between 70,095 to 72,799, which cover this value cover the true population means. So in this way, if I take another 30 sample, and then another, if we compute again confidence interval, you will see that will cover. In this way, if we do it again and again and again and again and again, on an average 95% of the time, the true average salary of the manager will be covered by the lower limit and upper limit, lower limit and upper limit of the confidence interval estimate 95% of the time. That is what known as the confidence, that is what known as the interval estimate. Okay. Now, the question is, if the sample size n is smaller, if the sample size n is smaller, then the formula will be this: x bar plus minus t, then 0.95 and n minus 1, which is equal to 30 minus 1 equal to 29, and then rest of the formula should be as it is. Okay. Now the question is, how can we find this value by using table or Excel? How can I use this value to find this Excel or table? You have to do these things. In Excel, you have to write like this way. If it is 95%, then you will have to write like this way. You have to write like this: norm, inv, non-inv, and then you have to write 0.025, and then you have to write here 0, comma 1, and then you will see negative 1.96, right? Now the positive one, how can I get? In order to get the positive one, you have to do it norm, inv, and then you have to go 0.975 and then 0 comma 1. In that way you will get your value positive 1.96 and negative 1.96. So what did I write in here? In here, this is the 95% confidence interval. Okay, this is the 95% confidence interval. If you take a look at that, this is the confidence interval. So here is a 0.025. Okay, here is a 0.025. 0.025. Okay, so now how much is in there? How much is in there? From here to all the way here, how much is in here? This all red thing is 0.975. That is why in order to find this value, I write here norm inv 0.975 and standard normal mean 0 and standard deviation 1. And then for finding this one, I put here norm inv 0.025 0 comma 1. Okay, 0.025 0 comma 1. This is what I got. So after constructing this not confidence interval estimate, so you can say with confidence 90%, 98%, 97% confident that your interval will cover the true mean 95%, 98%, 93% of the time. And now I want to show you how to compute t-value. In order to compute t-value when sample size less than 30, you just write t-inf and then go there point 0.025 is 0.025 and then degrees of freedom equal to 29 and hit enter. You will get your value like this. So let me see t-inf 0.025. Why they have like this way? T dot inf. I forgot to put the inf, and then I have to put here 0.025 and 29, and you will see this is the value. This is the lower limit, and that is the upper limit. T dot inf, and then I have to put here probability 975 and then 0 comma 29, and then you will see this is the um, upper limit, lower limit and upper limit of the t values. Okay, now one more confidence interval for the proportion. Confidence interval for the proportion formula is this: p hat plus minus p hat plus minus um, p hat plus minus then z 0.95 square root of p hat 1 minus p hat divided by n. Okay, divided by n. Now according to the sample, our p hat is 0.60 plus minus this is equal to 1.96, and here you will get 0.60 times 0.40 times n equal to, you have 30, so you will get two values. Okay, you will get two values in there. So this is what the proportion of manager who completed the training. So these are the two confidence interval that I wanted to discuss. Okay, after doing this, now I want to discuss what is sampling distribution. Now I want to discuss about sampling distribution. sampling distribution. Okay, now take a look at that. You took the first sample of size 30. Okay, and this first sample of size 30, you found the mean of them. You have a x bar 1. Another time another persons take another sample of size 30 and he had a mean of x bar 2. Similarly, it will go like another persons take another sample of 30, and suppose this is equal to x 35. So these are the mean. This x bar is the mean of a sample of size 30 of the manager salary. X2 is the mean of a sample of size another 30 of the salary of the manager. So this is the way. Now the question is how the distributions of x bar will look like. Okay. So you know Z, okay, it has a mean 0 and standard deviation 1. It looks like this. Okay, it looks like this. Normal, this is Z, this is 0, and it has a standard deviation 1. And there is a X which has a mean mu and standard deviation sigma. Okay, and now there is a x bar, which is the mean of the x's. This x could come from normal distributions. This x also could come from the binomial distribution, Poisson distribution, exponential distribution. So it has, as it is a sample, it is a sample mean. So it has a distribution which is mu sigma over square root of n. So this is the things. So z, x, and x bar. Okay, now I have to explain it by an example. Okay, I have to explain it by an example. So, take a look at that. Mean salary, mean and standard deviations of the salaries of the 2500 managers of Electronic Associate Incorporation, um, incorporation, uh, mean and standard deviations of the salaries of the 25 managers of the EAE are what are those number? Um, 71,800, 71,800, 71,800 and 399, 3999.2. Okay. Now a sample of 30 managers, a sample of 30 managers are taken at random. At random. Find the probability that find the probability that find the probability randomly selected. Find the probability that a randomly selected manager a sample of 30 managers are taken at random. Find the probability that find the probability that find the probability that average salary of a manager 1 greater than 75,000, less than 72,000, between 68,000 and 72,000. So the answer, first one is probability of X bar greater than 75,000. Okay, which is equal to 1 minus probability of X bar less than 75,000. Okay, which I can compute. If someone asks me to draw the figure is this. The original salary was mean was 71,800. So now I want to write it like this one. Then I have to find here a norm dist. So let me go there. I have to go there. I have to write here norm dist or that equal to 75,000. One minus, and then our mean equal to 71800 and standard deviation 3999.2, and then cumulative is true. Okay, so the results is 1. So greater than this is 75,000. I'm sorry, this is 75,000. Now this is what 0.211 the results is. Similarly, if I am asked to find the less than 1, let me copy it from there. If I am asked to find the less than 1, which I can do just by writing this and changing it to less than 72, right? Less than 72,000. 72,000 less than means 72,000. Just do these things. This is the answer, 72,000. Okay. Similarly, you can find the between one, subtract the one from the another, you will get the result. So this is the way sampling distributions problem can be solved. After sampling distributions problem, now we have to discuss about test of hypothesis problem. So any test of hypothesis problem has a 4 steps. Okay, any test of hypothesis problem has a 4 steps. So number one, setting up null and alternative hypothesis. And then number 2, calculating test statistic value. Number finding table value. And number 4, making decisions. Okay, these are the 4 steps needs to be done when a null hypothesis or alternative hypothesis, when test of hypothesis needs to be conducted. In our case, for the EAE data, suppose we want to test the hypothesis number one step. We want to test this hypothesis whether mean H0 stands for null hypothesis, H1 stands for alternative hypothesis. I want to test whether the mean salary of the manager is 73,000 or not. So the alternative hypothesis is not equal to. Whether it should be greater than or less than or is not equal to, that must be decided from the data. Number two is computing the value, calculated value, which is x bar minus mu 0, which is coming from here, and then s over square root of n. So now my x bar that I got from the data is this. My x bar that I got from the data is 71447. So this is 71447, and that one is 73000. And then s equal to 3779, s equal to 3779 point, s equal to 7339.26 point, where is that? S and 37, and then divided by n equal to 30. So after doing this, suppose we got, let me compute these things, okay? And then square root of n. Here is a square root of n. Now, if I want to compute these things, I have to do like this, then take like that. Then this is my sample minus this is my population is 7 to null hypothesis, alternative hypothesis. And then I have to put here times SQRT square root of 30, and then divided by square root of 30 and divided by um, s equal to our this, and then we got point negative 80, point negative 80 that we got in here, point negative 80. So where if it is positive or negative doesn't matter, make it always positive, okay? Z calculated value, and then we have a 0.80. Now I want to suppose test this at 5% level of significance. So that means I allow only 5% error. So that means 5% error will go in here. Here it will go 0.025, and here it will go negative 0.025. Okay, so that means in this case it is a step number 3. In step number 3 I can get z calculated value, which is equal to, from previous example I know it is 1.96 absolute. Okay, now at the fourth step you see z cal is less than z tab. This is the table value. Sorry, this is the table value z tab. Since z cal less than z tab, fail to reject null hypothesis. Fail to reject null hypothesis. Null hypothesis. So that is the way test of hypothesis should be conducted and should be finished. Okay, so I'm going to stop in here. I should go there, stop recording, stop recording.